Hello, in this video I'll just spend a little bit more time in section 5.7. We had talked about financial models. We had computed some values for each financial model. We didn't quite get to the last problem here, but we're gonna finish with that problem today in this video. So I just wanted to go over some of the things to look at on your calculator as well. So let's take a look at the graph of this and see if we can verify on the graph this problem that gives us the $59. So if we were just to graph this problem, well, let's turn it on, and there we go. 50 parentheses 1 plus 0.06 divided by 12 raised to the power of 12x. We're going to just put x there instead of 3, and we're going to try to figure out what that value is. Now we can, if we plug in this formula, we should be able to figure it out for every year using our table function on our calculator. Let's look at what the graph looks like. It should look like an exponential function that we graphed in the past. Let's set our window so that we can see it. So since 50 is there, that should be our y-intercept. So our y's are not going to be big enough here. Let's do -5. There should be no negative values, but we're going to go to maybe 75. And our scale is going to be 5 here. Now our x's, we have 3 years here is 59, so we're going to leave our, we're going to go to 15 years here, about 15 years, and we're going to start at 0, and we'll look at the graph here and see what it looks like. So we still are missing quite a bit here, so we need to go up higher on our y value. We still don't see enough of the graph, so our y value needs to be larger, maybe 125. Go by tens. Let's see if we have enough there. We should be able to see it all the way out to our value here as it goes to the side. So this is a pretty good estimate of our exponential function, and we could evaluate those by calculating our values at any given year, or we can look at a table setting, set up our table 0 to 1. We can then figure out what happens every year. So at the end of the first year you have $53.08. At the end of the second year you have $56.35. At the end of year 3, which is what we have here, $59.83. So we can see at the end of each year what amount would be in our account earning this amount of interest. We can also look at that on the graph. So let's go down to our problem here and just verify that this works at 8 years. So on our second problem, we're just going to verify that. So in this case, we have 3,000 1 plus, we can just type in our decimal we have here, 1.005. We figured that out, and then the arrow is going to be to 12t or 12x here, and the same thing. So this is our value, or our calculator value. Now we need to reset our window again because we want to go up to at least 5,000 here. So our graph's got to go from up to 5,000 here. So we're going to go actually to 8,000, a little bit higher, and we're going to go by 100 here for the scale. Let's take a look at the graph here. Our scale was not wide enough. We can see these double lines here, but 8,000 looks like a pretty good estimate for 15 years there. So let's just change our scale back so these aren't looking so close together there. A 100 is way too close. So maybe 500. See if we see, there's some marks there now. Doesn't look like two solid lines. All right, so we could actually figure out when this is 5,000 by putting in our line 5,000 here, in our secondary graph and finding out where they intersect. This would be our solution right here. That should be 8.54, approximately 8.53 is what we found. Let's just double check, calculate intersection, first curve, we can use that one, second curve, yes, estimate or guess, well, let's move close to 8.5 because that's what we think the answer is, and it came out to be the same value that we got in our logarithmic function. Got 8.54, this is 8.535, so that gave us the same value. We used our calculator to help solve. Alright, now on the last one here, we're just going to verify this. Let's see, we did not actually compute this value on the last video, so let's do that. So it was ln of 80 divided by 25. I didn't reduce that all the way. I could have reduced it even further. Let's see, that would be 5. 5 would be that would be 30, so 35 is 16 over 5 would be what it would reduce to, so it's ln of that divided by 0.07. That should be our answer for t. Okay, so ln of 16 divided by 5 divided by 0.07 should be our solution. In this case, we're saying it's approximately 16.6 years. And let's verify that on our calculator. 16.6 years. So we go back here, we clear this off. We're going to want it to grow to 80,000, so we're going to put 80,000 in here. Then we put in the formula 25,000 e to the 0.0 t, so that's going to be second e to the 0.07 x in this case. We don't have t on our calculator. Now we're saying it's 16 years, so we're going to have to reset our window again. And we got to get to 80,000 here. Now this is just 8,000, so we have to change everything here. So I'm going to go to 25 years. We're going to go by 5s. We need to go up to at least 80,000, so I'm going to go to 100,000. 1, 2, 3, 100,000, and I'm going to go up by 10,000 here for marks. Let's see what the graph looks like. All right, we have the intersection. We can see it. So we're hoping that's at 16. These are 5s, 5, 10, 15. There's 15, so it does look close to 16. We do second calculate, intersect, first curve, second curve, guess, we put it close to 16. All right, and our answer is the same, 16.6, gives us $80,000. So this is a calculator way to look at the exponential function and do some estimations of the solutions. All right, we're going to move on to the next video and talk about base B, and we're going to look at specifically this part of it right here. Sorry, this part right here, y equals ab to the x, and we're going to talk about this and how this relates to financial models as well. So that'll be our next video.